In this video, we are going to do a very important concept, a very fundamental concept, that is types of functions. Functions, as you all know, is something that takes an input, processes it, and produces an output. So, in a way, we can say that a function is something that establishes a relationship between these two sets. Set of inputs and set of outputs, set of domain and set of range. So that is what the function is all about. And in the same light, we are going to study today what kinds of functions there are. So this concept right here of types of functions is important because when we'll move on further, we will use these same concepts to understand how many types of sets there are and how a set can be countable, uncountable, countable, infinite, and other things. So moving on. So first type of function we have here is a one-to-one function. One-to-one function. As the name suggests, it is a one-to-one function. In this kind of function, one unique input in the domain set links to one unique output in the range set. This function is also known as injective function. Let me tell you why. Let's suppose you have two sets, set X and set Y. If a function is injective or if a function is a one-to-one function, then every unique element in set X, let's say X1, X2, X3, links to a unique element in set Y. There is one-to-one relationship. X1 will link to say Y1, X2 will link to Y2, X3 will link to Y3, and there is one more very important property here, that there cannot be any isolated X. Though there can be isolated Y's here, Y10, Y11 that are not mapped onto X, but there cannot be any X that is not mapped onto Y. Okay, let's understand it this way. For example, for instance, you are organizing a party at your house. Set X represents the number of people you are inviting. Say you are inviting Mr. X1, Mr. X2, Mr. X3, and set Y represents the number of chairs that are available at your house. Say you have these many chairs. So if a function is injective, that means that everyone you have invited to your house has a unique chair to himself or herself, and there may be empty chairs, but that doesn't matter. But our only concern right here in injective function is that every X should be mapped onto Y. Every chair should be every person should have this unique chair to himself. So formally defining an injective function would be, for every X1 not is equal to X2 that belongs to set X, there is a unique f of X1 that cannot be equal to f of X2 belonging to set Y. And that is what injective function is all about. Again, if you have invited these many people to your party, then injective function says that everyone has a unique chair to himself. No one can be standing, no X can be isolated. That is what injective function is all about. And here there is a very important implication that we will be using further. The implication is the cardinality of X given by nx. Cardinality means the number of elements in X. The number of elements in X is always either less than or equal to number of elements in Y if function is an injective function. Let us understand why. because you have invited these many people to your house and everyone has a unique chair to himself. So this means that number of people you have invited to your house are either less than or equal to number of chairs available in your house, because every x is mapped onto. There cannot be any isolated x. So the number of x should always be less than the number of y. Moving on from here to other type of function, that is surjective function. Surjective function. This is also known as onto function, and this is exactly the opposite what one-to-one function is all about, what injective function is all about. Let me define it first of all. Maybe you might understand it better that way. In a surjective function says that for every y belonging to y, for every small y that belongs to set y, there exists an x belonging to set x such that f of x is equal to y. Okay, this is just the opposite that injective function says about. Okay, let's understand this concept with the same old example. You have set x right here, the domain set consisting of elements x1, x2, x3, x4, x5 and so on and so forth, and you have set y right here, the range set that has different elements y1, y2, y3. If a function is surjective, then that means that every y right here should have a x associated with it such that f of x is equal to y. This means that every y right here should be mapped onto by some x. There cannot exist any isolated y. There can be isolated x. x5 right here is isolated, but there cannot be any isolated y here if the function is surjective, because for every y there should exist an x if a function is surjective. Okay, again coming back to that party and chairs example, you have organized a party at your house, you have invited people represented by set x, and the number of chairs available at your house are represented by set y. So if a function is surjective, then that means that every chair is occupied in your house. Every y right here is occupied. Though two people may sit on the same chair, or the people may remain standing, but that doesn't matter right here if the function is surjective. The only concern is that every element in the range set should have a x that maps onto it. And here we have again a very important implication. Number of elements in set x is greater than or equal to number of elements in set y. Cardinality of set x is greater than or equal to the cardinality of set y. Again, because every y right here is mapped onto by x. So number of elements in y should be less than or equal to x. Every chair in your house is occupied. So number of chairs available in your house is less than or equal to the number of people who came to your party. So this right here is a very important implication of the surjective function. Same we have a very important implication of an injective function. Now we will be combining both these concepts. A function that is both injective and surjective, one onto function. Let's see what type of function is this. Again we have two sets, domain set and range set, domain and codomain, whatever you may call it. If the function is both injective and surjective, then by the property of injection, by the property of one-to-one function, every x should be mapped onto y. Every x has its unique y. And by the property of surjection, by the property of an onto function, every y should have its unique x, or every y for every y there should exist an x such that f of x is equal to y. So right here, if you think of it in the terms of chairs and people example, then it is like every person has a unique chair to himself and every chair has a unique person to himself. Every chair is occupied. So this kind of function is known as one-one onto or bijective function. And this is a very important concept, and this function, this property is known as bijection. And one of the most important, and we have already studied that when a function is injective, then cardinality of x is less than equal to cardinality of y, and if a function is surjective, the cardinality of x is greater than or equal to cardinality of y. Now if a function is bijective, then every x has unique y and every y has unique x, then this means cardinality of x is equal to the cardinality of y.